Hello everyone and welcome back. Thanks again for your support. So I decided to create a series of videos in which we will be creating a massive bot for the Plants vs Zombies game. So as you know, when we are playing Plants vs Zombies, these Sunrays or sunlight, I don't remember what they're called in the game. But anyway, you gather them, and when you gather them, it's basically currency. So as you gather more and more, you can buy these plants and place them so they defend against the zombie waves. So the bot will be very complex at some point, but for today we just want the bot to gather sunray. So let's get to it. First off, we have our imports. So the first one is from detectors, import, match template, and sift method. As you know, we have a custom module called detectors, and basically what it does is it just has two functions, which is the sift one and the match template one. I have two whole videos explaining them, so if you want to know more about them, please have a look at them. But basically, match template is a simple algorithm that finds a small image within a bigger image. And sift basically does the same, but in a way more complex way. For example, sift can find the query image even if it's small or rotated, and match template can do that. So at first glance, sift should be more powerful, and basically it is. But sometimes it's just better to use match template for some stuff, as we will see in this video. Anyway, so since we will be focusing on match template, you should know that if it finds a small image within the bigger image, it is going to return this variable, which is maxloc. Basically, this is just a tuple that has the x and y coordinates of the top left part of where the query image was found. So as you may have guessed, we are going to be looking for the sun rays, and if we use match template to find it, basically the coordinates that it is going to be returning is right about here, which is the top left part of where the query image is. Our next import is CV2, which is basically OpenCV, the most important library that we will be using to bot this game. If you don't have it, you need to pip install it by typing pip install OpenCV-Python. Since I already have it, it didn't actually install anything. And anyway, the detectors module, I will leave the code for it in the GitHub. So you can just download the file and make sure that it is on the same folder as the pvzbot.py or whatever your main file is called. Our next import is from time import sleep. In here, you don't need to install anything because it already comes with Python. And finally, we are going to import py out of GUI. This one doesn't come with Python either, so just like OpenCV, you need to run pip install py out of GUI. I'm sorry, I didn't write it correctly. It's pip install py out of GUI. Yeah, since I already have it installed, it didn't install anything again. As you know, before you can actually create a bot, you need to break the game down in order to know what you need the bot to do for you, right? So the first thing we need is just to narrow down the area that we will be trying to manipulate. So I just took a screenshot and let's go back to Paint. I pasted it here, and basically all of this area here is useless, right? There's nothing to click on. And the plant inventory or menu is always there, so we don't actually need to look at it. Where everything goes on is basically on this square right here. So what I'm going to do is just take the data that I need to screenshot only this area right here. So if you're using Paint, you can just point your cursor over the top left corner, and down here you can see the X and Y coordinates. When you create or select the entire area, you can also see the shape, which is basically the width and the height of the area that you have selected. I already recovered the information that I need. I am going to create a variable and I am going to call it game_area. I'm going to set it equal to a tuple and I'm going to type the information in. What this basically represents is the XY, which is the top left corner of the area, and then we have the width and the height of the selected area. We are probably going to manipulate this information a lot, so it is very useful just to store it somewhere. The next thing we want to do is just load our templates. So as I had mentioned before, it is very useful to load your images, the images that your bot is going to be using, before you run your main function, because by doing this, you're saving a lot of time. If you open it every time you need it, you're going to take a lot of time from the computer. And it is a lot faster just to load it once before your main function begins running. So basically, the template that we want today is just this, image of the sunray, right? I already took some time and I already took a screenshot. I created this folder called imgs, and inside of it, you can see that I have the image of this sunray. Let's create a variable called sunray_img and open it by setting it equal to cv2.imageRead. And the first parameter is the name, in this case the location, which is the imgs folder / and then the name of the image, which is sunray.png. So this is going to access the imgs folder and open the image. We're going to set a second parameter to 0, and basically what this is going to do is just open the image in grayscale. Now that we have our template loaded, we can create basically our main function for this video, and we're just going to call a function and declare, a function and call it a gather_sunrays. We don't have any parameters for now, and we can just write a very cool description of what this function does. And what it does is just gather all available sunrays. So this is pretty cool to have when you have a very big bot, because when you call the function and you hover over it, or basically as you're declaring it, calling it, you can see the description here. And in the long term, when you're running a very big function, a very big code, a very big project, this helps you remember what that function actually does. The first thing we want to do is keep track of how many sunrays we are gathering. Let's create a variable called sunrays_gathered and set it equal to 0, because at the beginning of the function we haven't gathered anything. The next thing we want to do is just take a screenshot of the area where we are looking for the sunrays, and we're going to call PyAutoGUI.screenshot. The first parameter is the name of the image where you want to save this screenshot, and I want to save it on train.png. The second parameter is a tuple with 4 digits, and basically it is the XY coordinate of where you want the screenshot to start and then the width and height of where you want the screenshot to extend. So basically it is the start point and the area of where the screenshot should be taken. Since we already have that information in our game area variable, we can just call the variable right here. Now that we have this screenshot stored in an image, we actually need to open it again. So let's go cv2.imprint, and basically the parameters are the same. So something important here is that we are not calling imgs/train.png. So since we are not doing that, the image will be saved in the same folder as this Python file. And for that reason, we need to delete this imgs/ part of the name. So the screenshot is called train.png. We need to call it that same thing. And we're gonna set the 0 parameter just to open the image in grayscale. It is very important that whether you are using match template or SIF, that your images have the same channels. So if your template is being opened in grayscale, then your train image must also be opened in grayscale. Let's store this image in a variable called train_img. Before we continue any further, let's just make sure that our bot is working the way it should be. So let's just open both of these images. For that, we can call cv2.imageShow, and the first parameter is the name of the window. This actually doesn't matter. But, well, since the first image that we want to open is the Sunray image, let's just call this window Sunray. And the second parameter is the variable that is storing the image that we actually want to show, right? So you want to show the Sunray image on this one. And let's do exactly the same for the other one. Except that on this one, we want to see what is being screenshotted. And finally, we need to run wait key just so the windows keep showing and they don't just disappear as quickly as they appeared, right? Now, since the main code is inside this function, we need to call it so it actually runs. So as you can see, it is not the entire screen that is being, screenshotted. It is only the area that we selected. And for this one, the image is very small, but as you can see, it is the Sunray. So everything is working as it should up until this part. The idea of what we want to do now is we want the bot to take a screenshot and analyze it as many times as it needs so that it gathers all the available sunlight before taking another screenshot. So this is a little bit strategic because if we're taking a screenshot and then clicking on a sunray and then, taking another screenshot and clicking on another sunray, the bot will run slower, it's using more computer resources, and simply it's just way faster when you take one image and analyze it until it's no longer of use to you. Since we don't know how many sun rays there are on the image, we're just going to run a while loop and break out of it when the bot can't find any more sun rays available for gathering. To actually look for the image, let's declare a variable called result, and let's set it equal to our match template method. The first parameter in this custom function is the query image that we are looking for, which is the sunray image. And the second parameter is the train image. So let's set it equal to train image. So basically what this is going to do is look for this image inside of this image. Now obviously the bot took a picture of the code, but when it's actually running correctly, it is going to take a screenshot of the game area and it is going to look for the sun rays where it should look for them. If you have been following my videos, you know that the detectors module, specifically the match template method function, used to look for an image called train.png on your files. But I added this little piece of code, and basically what it does now is that if it detects that you are inputting a string, or if you're not inputting anything at all, it is going to try and open an image called train.png. However, if it's not a string what you're feeding into it, or if you actually feed something into it, like on this example right here, what's going to happen is it's just going to assume that it is an image object and use it to look for your query image. Also, as I explained before, if the match template method function actually finds what you are looking for, it is going to return a tuple. And if it doesn't find it, it's going to return none. So we are going to create a conditional, and basically if the result variable is a tuple, then we can safely assume that it found the sun ray. As you remember, result is going to be basically the x and y coordinates of where the query was found. So we're going to store those variables in result underscore x and result underscore y variables. Let's set them equal to result. So again, this is just the top left part of where the sun ray was found. If you watch my video about how to bot the Guacamole game, basically the mechanism is going to be the same. The first thing we want to do if we actually find the sun ray is we want to cover the sun ray found so it isn't detected again. To do this, we need basically the width and the height of this template image, because we want to create a rectangle big enough to cover the entire thing. To get that information, let's create a sunray underscore image width and sunray underscore image height variables. And let's set it equal to sunray underscore image dot shape, and let's split them like this. So basically the dot shape property is going to give us the width and the height of the template. The reason we are splitting it like this is because OpenCV first gives us the height and then it gives us the width. Normally we manipulate this information by using first the width and then the height. So far only OpenCV doesn't do that. So this is just a conventional way to do it. You can just as easily first call width and then first call height and then call width, and it should be returned in the right order. Now to draw the actual rectangle, we can call cv2.rectangle, and the first parameter is the image where we want to draw the rectangle on. So we want to draw the rectangle on the train underscore image. The second parameter is a tuple of where the rectangle should start. So if we take this one for example, we want the rectangle to start over here and to extend all the way over here. So the rectangle basically covers the entire thing and it is not detected by match template again. To get the top left of where the sun ray is, we can just call result underscore x and result underscore y, which, as you remember, are the coordinates of where the image was found. The next parameter is also a tuple, and now it wants the x and y coordinates of where the rectangle should end. So to get this, we can just call result underscore x and add the sunray image width to it. Then we just do the same with the y coordinate. We have the y coordinate and then we add the width to it. The height to it. So what this does is it just takes the initial coordinates and then it adds the width and the height, reaching the second part of the rectangle. The next parameter in this function is again a tuple with the color of the rectangle. Since it's actually just black and white, it doesn't really matter what color it is. So let's just make it red, which it would be 255, 0, and 0. And actually I'm not sure because the way OpenCV works is using the BGR format. So normally this is RGB, right? Now because the maximum value of 255 is in red, this should be red. But it's possible that because OpenCV uses the BGR format, it's actually blue. Doesn't really matter because as I mentioned before, it is just going to be white since it's in black. The image is black and white. The next parameter for this function is the thickness, I think. But basically, if we just type in -1, it is going to fill the rectangle the red color. So let's see if the bot is working so far. Let's call cv2.inShow. Let's just call the window test, and the image that we want to show is stored inside the train_img variable. Now let's run wait key, and let's give it a cooldown time of basically 10. I think that's 10 seconds. Let's just do 1 to make sure. Okay, so let's run it and come over here. Okay, so I basically ran the bot and it was never able to find anything. And this is because the train image is not being updated at all, right? So it's always looking for the sun rays inside our code window, and well, it's never going to find it there. So to fix this, let's just add an else and return if it didn't find anything. To keep this part of the code running basically all the time, we need to put the entire function inside a while loop. Now let's see how this works out. Now if I come over here and have it play, well, it's finding this sun ray and then it's finding this one again, and it's just putting the rectangles over them. It is working the way we want it to. What we want to do now is get the coordinates in the actual screen. So how that works is like this. We're just taking a screenshot of basically this part right here, right? We're taking a screenshot of this part. Now, the problem here is that when it returns the coordinates, Python or OpenCV is basically putting this part on the top left coordinate, and if we want the bot to click, let's say, over here, it is going to click right on that spot in our screen too. So what we need to do is add the logic to push the image back to its place, and so that it can click exactly where the image is in our screen. Doing that is a lot more simple than how it sounds. We can basically just create a variable called screenX and set it equal to the result X, which is where the image was found, and then add the game area the 0 index. So if we go back to this variable, you should remember that this is basically the x, y, then we have the width and the height. So we are adding where the image or where the screenshot starts being taken, which is going to push the coordinate to the right spot. And then we do exactly the same with the y coordinate. To get the screen coordinate, we can basically just copy, paste this, and change the first part for the y coordinate and the game area for the second index, which is number 1. Now, something that we need to consider is, well, the bot is not going to run as fast as we want it to. It's going to have some sort of delay time. And basically, as you can see, the sun rays fall, right? So this one is falling and falling. Now, if we run our bot, we run the risk that the sun ray is going to be detected like over here, and when it clicks on it, oh, sorry, let me go back to the game. Now, when we take a screenshot of it, it is going to detect it maybe up here, and by the time the bot finds it, the sun ray is going to be, well, you know, in a lower position. And also we don't want, so what we want to do is click a little bit downwards and match the sun ray to the position where it will be when the bot finally detects it. So the idea that I have is that when the sun ray gets detected, it's going to give me basically this coordinate up here. And basically what I want to do is click down here. So if it's falling down, it's going to catch it like right about here. And if it's not falling down, if it's just static on the same place, it's still going to click on it. It's not going to go like all the way down here. It's just going to go to the lowest part possible. So let's see if that works. Again, what we want to do is just click on the lower part of the sun ray. Let's go pi out of GUI, click function. As you know, we just need the x and the y position. Now the x position is going to be the same one, this green x. The only thing that is going to change is the y position. So to get it, we just scroll screen y, and then we are going to add the sun ray image height, right? So this should give us the lowest part of the sun ray possible, and if it's falling down, we are going to catch it. Now let's see if this is actually working. Let me save all my changes and run the bot. Yeah, so as you can see, it's actually working, and it actually did it pretty fast. Great, so we are catching all of our sun rays. We could say we are finished, but let's see what else we can do. What we want to do now is keep track of how many sun rays we have. As you can see, when the game starts, we have 50 sun rays. Let's add that to our bot. I'm going to create a current sun rays variable and set it equal to 25. Right? Now, when our gather sun rays function is running, we have a counter here. Now, if we click on the sun ray, we can assume that we have gathered it. So when we do click on it, we are going to increment this variable, which is again sun rays gather, and we're going to increment it by 25, which is the value of every sun ray collected. So as you remember, we are going to basically process the same train image over and over until we can't find any more sun rays. And when we can't find any more sun rays, what we are going to return is the total amount of sun rays gathered. Now, a mistake that I'm watching here is that if we have this value inside our while loop, it is going to be reset to 25 on every iteration. So let's take this out and put it outside our while loop. Now something we can just do here is set basically current sun rays and increment it to the value that this function is going to return. So again, if it doesn't find any sun rays, it is going to return 0. And if it does find sun rays, it is going to increment by 25 for every sun ray found. Now what we want to do is just print how many sun rays we have at the end of the session or loop. So we're gonna print the current sun rays. Let's run it and see how it works. Okay, so it clicked on one sun ray and now I have 75. Let's see how many our bot is counting. And at the end of the session, it is counting, let's see. Yeah, it is counted 75 of them. So it has the correct amount, right? Another thing that I want to do is just add some sleep time here, which is 0.5 seconds, half a second, just to make sure that after we gather a sun ray, the screen has enough time to take it out of view and the bot doesn't get confused and try to gather basically a sun ray that isn't there anymore. So this wait time here basically just gives the game window time to update. And I think that's it. We can actually just put all of this inside our main function. Let's add the index here, the indentation here, sorry. And then here let's just call our main function. So every time we add a new part to the bot, this is going to keep getting longer. Now let's see if this is just working correctly now. Let me save all the changes and restart the game. Okay, so we left our bot running for a little bit of time there, and I now have 300 sun rays available. If the counter gives us that amount, it means that our bot is a success. So let's stop it from running. Let's go all the way down, and we have 275. Now, the reason for that is that, well, the game starts at 50 sun rays. Right, let me just double check on that. And yeah, I don't know why I wrote that the game starts at 25 sun rays, it starts at 50. Now if we just add that 25 that we took out earlier, this should give us 300, right? So the bot is working the way it should. And let me just run it again, because I want to have a successful finishing to this. Yeah, okay, so the bot has been running for some time now, and I have 350 sun rays. So if the bot gives me 350 as a result, it means that it is a success. And it does. So we're finished for today. I hope you learned something, and I hope that I will see you on the next video.